Okay, so we've got 3 points of a triangle here and we're trying to find the interior angles. So let's start off finding the vectors that make up the side lengths here. So if I just move that down, I can fit a bigger picture in. So we've got A, B and C, and they've got position vectors 1, 2, 3, 2, 2, 3 and 5, 6, 0. Okay, so if we're going to find these angles, we're going to want to know the vectors so that we can use the scalar product. So to get from A to B, you need to go from 1 to 2, which is 1, 2 to 2, which is nothing, 3 to 3, which is nothing. To get from C to B, you need to do -3, -4, 3. A little tip here is if you want the this angle, because when you find the angle between two vectors, sometimes you can get this angle here instead of this one, which is just 180 minus. But a little tip is that if you do the vectors going towards a point, so A goes towards B and C both goes towards B, then you end up with the correct angle there. So starting to work out the dot product, then we've got 1, 0, 0 dotted with -3, -4, 3 equals modulus of this, which is just going to be √1, or more commonly known as 1, times the square root of 3 squared plus 4 squared plus 3 squared, so 9, 18, 16, 34. And then we've got cos theta there. Okay, so that's -3 over √34 equals cos theta. And so doing cos to the -1 then, hoping we've already worked this out, we get 53, it says to the nearest degree, so 51 degrees. No, 121 degrees, sorry. So that's 121. From this you can see I haven't quite drawn it to scale. Let's do a couple of the other ones then. Okay, so let's do the angle at C this time. So again, I want the values to be, the vectors to be coming into the point C. So the vector into the point C this way would be B to C, would be 3, 4, -3. The other one would be 4, 4, -3. And the modulus of those vectors, so I think we just worked this out, but 9, 18, √34, 32 and 9 times √41 times cos theta. Let's work this out, so 3 4s are 12, plus 16, plus 9 is √34 times √41 cos theta. So 12 and 16 is 28, 37, so I've got 37 over √34 times √41 equals cos theta, and doing cos to the -1 gives you theta equals 8 degrees. Okay, so that's that one. And let's do the last set going into angle A then. Okay, so to go from C to A is -4, -4 plus 3. B to A is -1, 0, 0. Using Pythagoras on both of those, this one came to √41 times 1 times cos theta. So I've got 4 over √41 equals cos theta. So that gives you theta equals to 51 degrees. Okay, what type of triangle is it then? It's isoscaline. Probably wouldn't have guessed that, but